excited to be here. To introduce myself, I'm Zachariah Holland. I am the chair of ACM San Antonio, the event that you're attending right now. Today we're going to be talking about, or we're going to have our guest speakers come and talk about an AI showcase that has been happening all month about web scraping and smarter summaries. So thank you for being here. A little quick introduction if you're not familiar with what we are or who I am. We are ACM San Antonio, otherwise known as the Association for Computing and Machinery. We are a locally chartered national professional chapter. If you haven't heard of that before, it's just a cool org to be a part of to learn about academics or learn about tech in the current world. But we are local to San Antonio. We are assisting in cultivating a thriving and professional community with engineers, scholars, and those looking to learn to connect. So welcome to our event. This is actually our first off event of our normal cadence of general meetings. So excited to introduce my team. Like I mentioned, I'm Zachariah. I'm the chair. With me, they're not here right now, but Gene Tigner is my co-chair and Mike Robinson, a treasurer. Funny enough, we are all UTSA alumni, so excited to be putting this on. Continuing on, if y'all haven't heard, we are a nonprofit. We operate based off the kindness and generosity of the community and those that participate in our events. We do have a membership that does allow you to get access at a discounted rate to ACM National membership resources. You can also donate if that's your vibe as well. But that membership right now is half off. Normally it's going to be $50 a year, but right now it's $25 if you're interested. If you have questions about it, totally seek me out, send me a message, reach out. But excited for y'all to be here for that as well. If you don't already, this is one of our many events happening this year. We've already had two. Those happen every other month. We normally keep it to like a February, March, like every even month cycle, try to keep it to the end of the month. But we keep these calendars pretty updated. You can mainly find us on Luma, a pretty free calendar website, as well as Meetup, pretty popular. But if you're looking to get a part of the tech scene, there is a Discord link that leads you to DevSA or Dev San Antonio. If you're not familiar with them, I could talk about that for another hour, so I won't go into it yet. But it's definitely where all the tech and all the orgs are communicating right now. But without further ado and talking too much more about, we are introducing my speakers, Dr. Ki Yang and Sohar, into speaking about web scraping and smarter summaries. This is a part of, like I mentioned, our AI April showcase hosted by the Geeks and group. If you're interested in that, I'll talk more about after they're done speaking. But there is a big showcase happening on May 10th. That means prizes and a chance to compete with other people or join a team and create something. This is just one of those events happening in that series. So if you're looking to participate, looking to build off a project of what's happening today, I'm excited for y'all to get a part of this. Without further ado, welcome in.
Thank you, Zachariah, for the introduction. While Sohan is getting our slides ready, I usually get used to that talk without slides. Basically, I'll talk at the first slide, which is the title. So thank you for having us here. We're happy to share. We're from academia and UTSA more specifically. And we'll talk about some, hopefully it's tutorial or demonstration about AI agents in web content summarization with explanations. That's can you move the slides to the extended one? Thank you. That'd be great. So let me start with the introduction with two of us. My name is Kian, like Zachary introduced. I'm an assistant professor in computer science department at UTSA, and I'm also part of the different student at UTSA School of Data Science, Metrics AI Center, and of course our CARE AI cohort. Sohan is our AI expert in this line of work. That's why he's also here today. So, okay, great. Thank you so much for getting the slides up. Where's my second one? Okay, that's our title slides. So just a brief introduction of our big research cohort. So I started this cohort for AI responsibility, or CARE AI for short, about, I think, 2 years ago. So we are a group of researchers in, you can see, I don't know whether you can read, but from a variety of disciplines who all care about AI-related issues. And I'm also showing some students we have on this right. And we have students from PhD program, master's, undergrad, and even high school students. So that's the introduction who we are. And I want to start with an overview of the workshop today. It's about an hour we scheduled. It will be basically two parts. The first part will be delivered by me. I will set up the stage and talking about the background of AI agents and more important about the explanation or interpretability of AI agents and the method we will cover in the tutorial, the line method. And then we'll have a short QA session after that. While switching to Sohan's part, we'll have the tutorial actually. We'll have some step-by-step demonstration of how we build a workflow AI agent with actually different agents to do the web page scraping, summarization, and later on labeling some topics for the summarization. And of course, more important part, how to explain how the labeling agent works, for example. Then at the end of the workshop, we are scheduled for like about 15 minutes or so for you guys. Actually, you all have the access to the tutorial notebook to freely explore the part that interests you after Sohan's step-by-step demonstration. Of course, that's a second QA session for more detailed technical questions. And I apologize ahead of time. I need to step out a little bit early. That's why we have two QA sessions. But Sohan is actually better than me answering technical questions, so we have the right person. Okay, let's get started. So let me talk about AI agent for a few minutes. Before that, I want to do a quick poll. How many of you have used all the chat box, or no matter which company it's from, whether it's ChatGPT or Google's Gemini or other like visual? Okay, almost everyone, right? So that's kind of of course, that's advanced language model driven agent. But in this case, when I talk about AI agent, I'm more tends to the definition that coming from academia community that we define it as more broad sense, that they are the system that can handle automatically or semi-automatically specific tasks based on users' inputs or specific instructions, and they will always utilize some AI techniques. It can be the traditional machine learning method before the language model taking out the game, and it could be also some other traditional like computer vision techniques or natural language processing techniques. So all this kind of a system will serve as one of the agents, no matter it's simple or complex, like the language model. So I'm showing here several, it's not a full list, but several important features I want to highlight about AI agents. Of course, based on the definition I'm going with, you can see it's the first thing about their autonomy or semi-autonomy means that they can going on and on without worry about you're tired or exhausted. That's better than our past human, right? The second one is about their learning capability, of course. They are designed to learn actually from the past information, new data from the user's interaction to improve their performance, to give suggestions, to answer your questions, etc., right? And the third key feature is about they are always task-driven. Of course, this newer chat box are more powerful in terms they seems to be able to handle all kinds of tasks. But before that, most of the AI systems are actually designed for specific tasks. Like they are doing recommendation, like they are helping you helping the self-driving part, etc., etc. We'll see a few examples in next slide. So they are designed to handle specific tasks to have the best performance, right? The fourth feature I want to mention is about their interaction with the environment here. So like they can be interacting with physical environment, means like thinking about the robotics. They are actually navigating through the space. They're trying to learn where is the object, where is the wall. They're trying to reach to the destination they want, right? That's a physical environment. But these days, with more recent like chatbots you have been played with, they actually interact with more digital environment, right? They are interacting with websites, with applications to collect more information to do the task. So they can interact nowadays different kinds of environment to collect more information to improve their behavioral performance. So the second last feature I want to highlight is their ability to do very highly customized or personalization. As you can see, you can teach them to, okay, this is my customized AI assistant to do a specific kind of thing. This is very doable these days because of the revolution or evolution of the technology. But last feature I want to briefly mention is about their reactivity or proactiveness. Means that some AI agents, they are designed to be reactive in a way that they are response to some changes. For example, if you have a chat box or AI agent for making some financial decisions, so they will respond to the market change, right, to do certain things. And the proactive thing is they can also learn from the past information to predict the likelihood, like a future event, to prevent something bad to happen, right? That's their proactiveness feature. So without the feature quickly walk through, let's look through some example or applications. As you can imagine, there are a lot of applications of AI agents. They can be assisting the diagnostics in healthcare or patient monitoring, or just give a suggestion to doctors to make their decision about certain things, right? They can also, this is virtual assistants. We have all that already, like Siri in your phone or Alexa, like all the assistants in your smart home devices, right? They also give like a very kind of a clever response to different kind of tasks. They can answer your questions. They can help you to adjust your smart home devices, etc., etc. And we also somewhat has the AI agent in the autonomous driving or vehicles. They help to do better job in self-driving, avoid pedestrians, avoid tasks, etc., to do traffic management. A more newer kind of application is like when AI are serving as a teacher. Now it's a digital teacher to build a more customized learning experience, so they can personalize to different kind of students to improve the efficiency in learning. There's a financial one we talk about. AI already, a lot of system helps in making financial decisions in a very short time, because they are like the market change very quickly, so you need to make some decision very fast. Humans slightly slower in that case. And of course, the other case is gaming is another one. In virtual reality, AI agent can help serve as NPCs to give you more personalized interaction responses, etc., etc. And the last kind of thing is when we have this AI agents in manufacturing, this already happening. So they can perform very accurate instructional, precise instructions, so that you are manufacturing some products without error and issues. More future kind of things, they can also serving as farming robotics, kind of in agriculture. That will be the smart farming in future, hopefully, to also saving some human labors to do the job without issue or error, and can do the job of 24/7. Right? That's the benefits. Since we're talking about the benefits, I want to quickly summarize the benefits and challenge. There's always two sides swords. You can see already based on applications, there are a lot of benefits that we can already say. They are very productive and efficient in a way they can perform the tasks exactly based on the instruction without stopping. So we don't worry about the issue and the maintenance for that. And because they can learn all the knowledge or information from the vast amount of data, that's how the language model works. They can actually improving the decision-making process when they learn something that human cannot easily learn. Of course, they can, when they unfortunately replace some positions or facilitating the working process, they can help the business to save costs, and they can be easily expand to a large-scale setting, so they are much more scalable than a human driving kind of a system. Last one, we mentioned that they can be built very personalized in a way. The experience be more satisfying. But unfortunately, at the meantime, there are a lot of challenges behind this AI agent. Come in, please. So first one I want to start is because they learn from the vast amount of data, and unfortunately, data these days inevitably embed some issues from our society, and then the AI agents perpetuate or even amplify this kind of issues in their outputs. So without kind of intervention on this kind of thing, there'll be a lot of issues. You guys might heard a lot of weird story about the Google's Gemini. That's last year, right? I don't remember when, but it's a funny story about their EI image generation. The second issue about the privacy, you can say that because a lot of personalization happening, to do that, they are asking a lot of information about yourself, right? Are you worried about how privacy? Is there any privacy invasion about that? Really, I'm using this personalized AI agent. How much they have learned about me, right? There are a lot of ongoing effort to do this or to avoid or to figure out whether there is some privacy invasion of the AI agent. The third challenge is one we will focus on today is about their opaqueness, because they say they are black box to us. Right? We don't know how exactly they are making certain decisions. We need explanations. That's why we chose one of the explanation methods to demonstrate today to see how much importance of this explanation can be asked to help us to trust this kind of AI agent better, right? So the last challenge is about governance and regulation. As you can see, because the size of the AI agent now and the black box nature of them, it's new to us, right? As a society, how much human oversight we need for this AI agent to just prevent the harmful results. We are still learning this as a society, as a together, industry, academia, governments, regulation agency. We need to work together to figure out what we're gonna do with this. Right? That's the last challenge. Okay, now since we are on the same stage about the AI agent, what they represent, let's talk about the transparency or the explainability issues. So before all this happened, like 20 or even, 40 years ago, when you come up a model, you're likely going with this kind of more, what do we call, interpretable model. So there's a decision trees, there are a regression kind of model where we know exactly how this model are working. We can read how they work. They are white box to us, right? But now we're moving to the kind of when you can see that there's a nature or essential trade-off between the accuracy and explainability. When the AI agents or the technology behind them get better or more complicated, more complex, you'll get better, higher accuracy from those complicated models like deep learning neural networks or now the language models. But you'll see zero explainability because it's impossible to infer and track how they work. This plot is basically showing a trade-off between them. If you want more explainability, you usually go with simpler model like the decision tree we saw in the previous slide or the regression model that we know exactly how they work, so we get better explainability. But meanwhile, we might sacrifice some model performance in terms of their accuracy. So there are a lot of ongoing effort in the live world. I call this explainability AI or XAI for short. So based on type of explanations they are generating, there are two kind of big categories. Those generating global explanations and those generating local or individual ones. The global method aim to, I highlight a few strategies here in blue, but the global method basically aim to provide you a overall understanding of the model behaviors. Meanwhile, the individual or local one is focused on explain to you why a model makes a certain specific prediction for this specific instance. Of course, they go with different strategies to generate the explanation. I won't go into details. All this serves the purpose like interview you. If you're interested to learn more about that, feel free to reach out or talk to me, ask questions. Of course, if you are satisfied when you build a model, if you feel like, okay, actually the simpler model is already good enough in terms of accuracy, the performance is acceptable, then you should definitely choose to build an interpretive model rather than choosing the complicated one if you are satisfied with their performance. That's the kind of simple model I list there. So with this ongoing, that's like one kind of categorization of XAI. I'm showing another categorization showing slightly different. They are categorized method based on whether a method is model dependent, means that they are designed to only for specific kind of model like regression kind of thing or tree-based thing, or they are model agnostic, means they can apply to explain the underlying behaviors of different kinds of models. Like the line I highlighted here, we will introduce in a second, which is a model agnostic method. How I'm doing on time. I think I'm taking a little bit more time than I thought, but that's okay. We have some time budget. So let's talk about the Lime, as we mentioned specifically, and Sohan later on will show you how Lime actually works, give you examples with specific tutorials. So I'm giving an example like you want to build a model to predict whether a patient has a flu based on their historical data, like whether they have some symptoms, like they have fever or not fever, here is headache or sneeze, etc., etc. And you have this model built, and then Lime can be applied to explain, okay, for this specific patient, actually, if you predict it as they will have flu, what actually contributes to that prediction? It's the sneeze symptom and the headache in the past actually contribute to your prediction as having flu. That's kind of the format of the Lime explanation for tabular data. Lime actually, yeah, I have the full name. Lime is short for local interpretable model agnostic explanation. The name already says a lot, right? It basically says all the features of this method. They actually proposed, I think it's almost 10 years ago, but they got a lot of attention. They got almost, I want to say 23,000 citations until now. So it's, if you got this many citations, it means that the method really useful, practical, and it can be applied in different applications. That's why they got a lot of attention. Next, let me quickly show the key intuition behind the Lime. We mentioned that Lime is model agnostic. It can apply for different kinds of model. That's one advantage. They are also, they can work for different modality of data. By modality, I mean they can work for tabular data. They look like the data you store in an Excel file, row by row and column by column. Column usually is your feature, row is your data points. That's tabular data. They can also for image and text. I'll show image. I show image here, and I'll show text example in next. So the key intuition behind Lime is that they are proposing this technique that they're trying to modify your input data, no matter it's some rows or some images or some text like a sentence or a paragraph. They modify in a way that's very cleverly. They focus on kind of what they call it as a local neighborhood, like this area. So you always have a target you're trying to explain, right? That's how Lime works. For example, I want to explain this bold red plot here. That's a patient's prediction I want to explain. Here, I want to explain, for example, the classifier is built to decide whether there is a tree frog inside this image. This is our target try to explain. And from this target, they can define this local neighborhood, basically the neighborhood where your target is. For tabular data is clearly, I'm visualizing in 2D dimension, but you can do it in higher dimension, but you can usually find the neighborhood. And for images, the neighborhood is defined by some new images with some masked areas they created cleverly. And with all this neighborhood, they can basically sampling new points here in this neighborhood, sampling new image, mask some area of the image, and they create a data set called modified data points. With this modified data points, what they do? They learn actually a surrogate model. Here is a new line. Usually the surrogate model is a very simple model, like a regression kind of algorithm. And they learn that over the modified data set. So based on this surrogate model, they're trying to simulate the behaviors of your original model in this neighborhood, right? And that surrogate model can accurately kind of simulate your behaviors. That's why they can use a surrogate models, because surrogate model is simple and it's a white box to us. So they rely on the surrogate model to generate the intuition or explanation for your target point. For example, I'll use the image to show here. When they do all the mask with the images and learn the surrogate model here, then later they found out, okay, this mask image with only the frog's head is showing actually contributed the most to your surrogate model's prediction. Then they decide, okay, that's your explanation. That makes sense, right? For this frog image, that part is actually matters the most for your prediction as a tree frog. Make sense? Tabular data are always similar. The output explanation we saw in the previous slide is like this, because they use features now to mark how important of the local area for the prediction. Now let's look at actually the task as the last example. Task is similar to tabular data. They will do also the modification by removing certain words, and they learn the surrogate model over the new sentences or paragraphs. Then their explanation is like this bar plot, while the y-axis or the legend of bar shows that that's each word in your input you're trying to explain, and the color represents the importance of this word to a different like a label. Like you have now classifying this paragraph, whether they are talking about atheism or they are talking about Christianity. So I think this is purple or magenta is for the atheism. It means that, okay, for this model, line found that the word posting, host, read is contributing a lot to the prediction of atheism. But you see the problem, right? They are really, these words are doesn't tell it about atheism at all if a human reader will look at that. That's how Lime's explanation helps us to reasoning about, can we trust this model to predict whether a given text description is about atheism or about Christianity? Apparently no, right? Because they are making that prediction based on some nonsense word. It's actually not tells you anything about these two labels. That's how the Lime explanation can help us to understanding whether the model's behavior is reasonable or not, and further also gives us some insight about how can we improve the model to fix this issue. They're usually an issue. In this case, it's basically in your data set, the atheism label, the ground truth label is always associated with this posting. Weirdly, it's because the data set nature is from some email kind of a benchmark data set. But you can easily fix this, right, based on this intuition from Lime. Okay, I'm almost finished. I'm taking 10 minutes more. So I think hopefully our brief introduction of AI agents and Lime gives you some background. When later Sohan is walking you through the actual agents doing some tasks and using the Lime, if you feel more comfortable with understanding them, of course Sohan will give you explanation. So the second part of the tutorial we will present today, or Sohan will present today, is we are building, this is usually called workflow AI agent systems. Means that your step, there's a specific order between all these different agents. So we're starting, the task is about doing web content summarization cleverly, and we're trying to explain why they summarize and labeling the topic in this way. So we're starting from web page, starting from URL and URL you are interested in understanding. Then we are first getting a scripper to give us the clean content of what happens in this web page. Then we are asking a summarizer, the agent, which is a language model. I think it's T5, it's not language model. It's, I think, BERT kind of thing to summarize the web content and give us a very short summarization, like a few sentences. Then we have three different, let's call it topic labeling agent. What they do is, okay, I'm reading this a few sentences. I'll decide, is this talking about sports? Is it talking about scientific thing? Or is it talking about business? So they have this input kind of a set of category of topics you want to labeling them. And we will have this 3 classifier agent to do that same job. Then later we will apply line to every one of them, try to understand whether their labeling makes sense or not. Are they really using the right words or terminology or short terms to labeling this as scientific or as business? That's the tutorial in the second part. So the tutorial basically is a notebook. It's a Google Colab notebook. So everyone can open the notebook by entering this URL. It's a tiny URL, so it's easy to type. tinyurl.com/AI workshop and the date today, 0430, or you scan keyword like you already figured out. Okay, well, this is, I want to highlight or briefly walk you through, and then I'll handling over to Sohan to starting or preparing for the second part. Well, if you have any questions, I'm happy to talk more about that. Feel free to access the tutorial notebook by the code, by the URL or by the QR code here. Any questions? Oh, I guess I did a good job in terms of explaining things. But go ahead.
Quick question, when you're talking about web scraping, do you use any particular tool? Because I was taking a course in using Scrapy.
Mm-hmm.
So I don't know if that's one of the ones you use.
We're not using Scrapy, correct me if I'm wrong, but I think we are using a specific Python library to do that, which is called Article, if I'm right. Yeah, I think in the previous slide, but you can also check it in the code directly. So that's a good question. There are a lot of scraping methods you can try. Of course, you can also ask a language model to do the scraping. They are surprisingly very good because they are powerful, as you can see. Yeah, web scraping is a very traditional kind of field. Before language model, people figure out how to do this very efficiently, automatically. But now, seems like with the language model, yeah, I don't think there are a lot of challenges remains. They can handle that very good. That's why we don't really focus on the scraping part. We just, okay, there are a lot of libraries can do the job. We pick one that can do the job very reasonably, and we focus on the second later part. We do the summarization of the web content. Make sense? You want to just ready for switching then? Has everyone scan code or have access to the tutorial notebook? It might take a few seconds the first time you're trying to load that. I think Google Colab sometimes is weirdly doing that. But if you do it again, eventually it will show up, or you'll try the second time, it'll show up. Yeah, that's exactly the notebook. You want? Okay, if no further questions, Gabriel will share the context of us, and I trust you can also find me easily online. If you have additional questions, feel free to reach out and ask. And then I will hand over to Sohan to give you guys more detailed, technical, specific, and code-based demonstration of how to build that workflow to do the better summarization. Make sure when you talk, make sure everybody have access to the notebook.
Thank you, Dr. K, for providing the background. So myself, Sohan, and I'm pursuing PhD in computer science at UTSA. Today, I will walk you through a notebook called AI Agent for Summarization and Topic Labeling. The main goal of this notebook is to make you understand how you can choose models for your task and how you can use that model using the codes and how you can explain the model's response. So Dr. K already told you that what I'm going to do here. Like first, let's say I'm giving you a URL of a web page. So the web page is a long article, right? Like it can be 10,000 words. So from the 10,000 words, we are going to summarize the article to have a few sentences, and then going to label the sentence as it's health, or it based on the science or history or politics on it. So if you already have this notebook on your laptop, let me tell something about the Colab. So Google Colab mostly have already installed the prerequisite libraries like generic ones, and we're gonna need some other additional libraries I'm gonna install on the step one. So first, I'm gonna tell you, if you also want to walk through this notebook, go to this section and change the runtime, select the T4 GPU. So it will make the process faster because the model is big model. So if you have the GPU, it will faster one. And save it. So on the step one, I'm going to install some necessary libraries. So first, let's run this first. So if you're also running this, let me know if you face any problems in running the code flow. So first two library is used for the scraping part. So the newspaper and HTML clean. These two library helps to get the articles from the URL. So what I am doing here, so in this step two, extracting the clean text from the website. So in this step two, I am importing the library, newspaper, and article. So providing the URL, I just randomly selected the Wikipedia URL, like it's about the James Webb Telescope. So providing the URL, the library parse the website contents, including the HTML or other additional information. So only in this text, article.text gives you the clean text without any HTML included tags or some additional information. So where I'm printing how the text look like. So just printing the first 100 characters from the article. So it works fine, right? So no HTML tag, it's clean text. Then I just print the length of the words, how many words are there in the article. So it's like more than 9,000 words. So it's a pretty big. On the step 3, I'm going to summarize the article in using the Google's T5 small model. It's a small model. It's available in Hugging Face transformers. Yeah, have you heard of any Hugging Face website? So all the open source, most of the open source model is available there. So yeah. So using the transformer, I'm going to load the T5 model. So let me run the second. So using the transformer library, I'm going to load the model. So T5 small is the name of uniquely defined name that available in Hugging Face. So you just put the name here, and the model will be loaded by this library. We also need the tokenizer. Do you people have any idea what this tokenizer is? Or I can just. So tokenizer is like a dictionary for the model. What it does, it's like a model doesn't know the English language, right? It doesn't know the word. Tokenizer is like putting ID to a word, so in token. So it's like a translator. So tokenizer is like a translator that translates English language to some IDs that model can understand. So for running the model, we need the two things: the model itself and the tokenizer, the dictionary that transforms the English language to IDs. So the next thing I'm doing here is like checking the environment has like any GPU or you're just using the CPU. As I told, if you change the runtime to GPU, it will have the device, will have the CUDA that use the GPU. Then I'm just moving the model to GPU. That will process faster. So the T5 model is like a sequence to sequence model, is generative model. So it takes the input and whatever you told, it do like the ChatGPT one. So I'm making a prompt that summarize the text. So I'm putting the summarize. You can try another thing like translate to French or Spanish. Put the sentence, it will translate to and give you the results. So here I just need the summarization. So I just told in the prompt that summarize, and I'm putting the web text. Then having the input text, I'm providing it to the tokenizer that translate or encode the input text into the machine learning tokens like the numbers, unique IDs. So here you can see some parameters. The max length is 1024. So I'm not using the 9,000 tokens because the model won't handle that much long text for now. So I'm using the 1,000 tokens from the article and putting it to the device. And then I'm asking the model to generate the outputs. what it does, taking the input IDs, and I'm asking that the summary won't be long more than the 500 token. And it gives you the summary. Let's run this. So the model generates the results in the IDs, and human doesn't know the IDs, right? So I need also the decode the output. So what's that? Running this model. So first, sorry. Can you see? So let's print the summary. So it's saying the length of the summary is 50. Like there is only 50 words. And the summary is like the waves, diameter or something, Hubble oscilloscope. So it's summarizing the text. It's working. So the next step, what I'm gonna do is use two pre-trained zero-shot agent. This is also a transformer-based model. So the first one is Facebook BART large MNLI, and the second one is XML robot large XMLI. This type of zero-shot model, what they does, takes two sentences. They take two sentences and predict how they are related. Like, are they make contradiction? They are neutral, or they are entailment. So what I'm doing here is like I have the summary, like 4 or 5 sentences. I don't know what the summary is based, like in the history or politics or nothing. I don't know. So I will create some candidate labels, like history, politics, education, science. And I will try every pair, like the summary and the pair with education, pair with politics, and check how they are related. Is there any contradiction or how they are related? The related is score actually in the entailment. So there will be 3 class probability, one for the contradiction, one for the neutral, and another for the entailment. I only focus on the entailment for this notebook actually. So I'll extend the function later. First, let's say load the first model. So first I'm gonna use the XML robot large XMLI. The same thing, I'm going to load the model first using the name and the tokenizer. So the library handles how to load the models and downloading the models, also the tokenizer. Then I'm going to move the model into the device, like using the GPU. And I told you that I'm creating some candidate labels. So I'm suspecting the tokens the summary might be in the like education, science, health, politics, entertainment, or history. You can add or remove anything you want. So just test yourself if you want to. Then I'm calling a function get entailment score, like the score I am looking for, how they are related. So I have the summary already. I have the candidate labels. I have the model and model's tokenizer. So what this function is doing in here? This function is creating, I told you that it's creating pair with the every labels. Like in the candidate labels, we have education, science, health. So for every label, it's creating a hypothesis. Like it's telling this example is about education, this example about science. So for every pair, it also like tokenizing the text, like the summary and the hypothesis. Then moving into the device. And here I'm asking the model to generate. It's a bit different from the T5 model. It's a different type of model. It's a zero-shot transformer model. So here it's doing it, I'm telling it the torts no grade. That means I'm not fine-tuning or training this model. Just do the inference. So the loss is actually the last layer of the models. It is the last layers of the models is taking the weight and the probabilities, and from the losses I'm performing the softmax to get the probabilities for the contradiction, neutral, and the entailment score. So I told you the entailment on the last position, so it's 2 of the index. There is 3 class. So I just only focus on the entailment. That's the entailment. If you put 1 here, that will be for the neutral score. If you put 0, that will be the contradiction score. So after running the model, you can see the results, predicted topics. So for the first model, the Robert 1 is telling that the summary is mostly with the entailed with the health. It's not the score you get like in 70%, 80% score, because it's not like the predict or classifier model. It's like a zero-shot model. It just gives you the how similar they are, not like the prediction confidence. So it's saying that it's mostly related to the health, and that is not correct. We'll explain that with the line why it's not correct. That's why I pulled this model to as an example. Then we are going to use the Facebook Butler's model. The same thing here I'm doing, loading the model with the model name, and I have the same candidate labels, and I'm calling the same function again, because these two models is exactly the same model, just the difference with the the data set it has been trained on. The same thing I did, but here the model get a correct prediction. Like it's saying that's
you got the data labels from before, like outside of this, like doing initial analysis, like reading the CSV or whatever file you had.
So I am not fine-tuning any models. So these models are already trained, and I'm just using this model from the hundreds. Right?
Yeah. So quick question: the candidate labels.
Yes. So I just put the
those
candidate
are derived already.
No.
Previous.
No. You can add or remove any more candidate labels.
Okay. So you created these education science, etc.
So you can change it. Okay. If you want to try, remove the science and see what happens. You can do that.
Oh, cool.
So this model works better than the last one because it's giving you the correct prediction. We also see how it explanations using live. So on the next step, I'm going to use different type of models. These two models was zero-shot model and prediction on the neutral contradiction. Like having two sentences, it was giving the similarity score. This model actually has predefined whatever your question was. So this model has predefined 16 classes. So it was trained on IPTC news code taxonomy, and it has like a 16 classes. So it already has been trained for the classification classes. So in this case, I just load the model in the same way, move the model to the device, same tokenizing things, and running the models with the logics, getting the last input. Here we can see a difference. Last time we used the softmax, here we use the sigmoid. So I told you the softmax is for like giving the probability for 3 class that sum to 1. If you add all the sum, it will get V1. In sigmoid, one summary can have multiple classes, right? So it can goes to the science, it can goes to the technology, it can goes to something else, education. So that doesn't mean all the prediction will sum up to 1. That's why they use sigmoid, and their confidence get to like 70%, 80% or something, you can see. So you were asking about the labels, right?
Yes.
So in this case, the model has a configuration. So ID to label, they have 16 label. So in this model, you have the predefined candidate labels. You can't remove or add anything. So let's run this model and see the results. So this model gives you the exact correct predictions. Like it has been rigorously trained on the news section. So you can say the summary actually already news already covered about the James Webb Telescope, right? So the model has been trained on the news. So the model knows it's about the science and technology. So it has like a 99% confidence. So it's a very good models to have. So until now, we just get the articles from a Wikipedia site, then we summarize that. We tried 3 models for like giving the predictions. And we're now gonna use the line to see the explanation, how the model's behavior. So Dr. K already described about how line works. I'll just give you another brief that I had. Let me go to this one. So let's say I have only this sentence. So what line does? Line creates several sentences like this one. So it can create another sentence that doesn't have this keyword. It's missing. So that's how it creates like number of summaries. Like I can define like create 50 summaries like this one. So perturbing the sentence, like sometimes remove this one and other things, removing that one. So they will create a different version of summary like a 50 or something I'll define. And they run the model on this text and get the prediction. And that's how they decide which keyword has like most influential word. Like if we remove the most influential keyword, the model will perform less, right? So that kind of thing line does. In a high level, but not exactly. So I'm going to explain this function later. First, so for this portion, I'm just having just the class from a line text explainer that takes only the candidate labels first. So I already have the candidate labels and explanations. This function actually get all the word attribution. Like for every word, line gives you a value like 1.5, 2.5. That's how it's weights on the prediction. So this line explanation takes actually the summary. So line internally chain part of the summary creates a lots of summary to test, and it takes another function that's a predict probability. Predict probability function, what it does, you need to define for the line. So in the predict probability function, line will try to pass the text, and predict probability will give you just a score. And I can define the number of features to work with. Like that means I have 100 of words in a summary. I will just tell line, okay, just focus on the first 50 top weighted tokens. That's the thing as a number of features. And the labels I already told that's candidate labels, and number of samples that defines how many versions it will create. Like from the summary. If I say the 10, it will create the 10 versions of the summary. Let's go on top. So I define a function that run line explanations for all the three models that take the model, that takes the tokenizers of the model, that takes the summarization, candidate labels for the model, and it asking it's about the multi-label or not, because line works differently with the multi-label and multi-class. Like the first two one, the Facebook or NLI, like Roberta, that is different with the last one, the news category one, I thought. So that's why I needed the. And by default, I'm defining that number of samples will be 200 and number of features will be 50. So in the predict probability, they have the list of the text. The text means all the variation of the summary. So looping through all the variation of the summary for the multi-level means the first two sections that will use only this portion of code. So they are doing a batch prediction that will be more faster and encoded that, get the logits using the safe softmax, it will get the prediction. It's doing the same thing, just the same thing I already showed. Just getting the prediction for all the summarization version. So on the last one, the news category use this version. So they use the sigmoid to get all the probabilities for all the versions. So let's run on the Roberta model. Let's see how it works. So if you change the number of sample to, I'm using a 300 here. So if you change, like increase the version, like the 500 or 1000, it will take too long time to calculate. So for the demo, I'm just using the 300. It's still taking a lot of time. So you can just change the value.
Sorry, you get more accuracy with higher samples.
Yes, obviously. So the higher the sample is, the more you, okay. Run and see. So you can change the number of samples and number of features to see their explanations get changed. And just wait for it. So, yeah. So as you know, the first model predicted it as a false as a health, right? You remember the first model put the summary as a health, categorized as a health. And you can see I plotted top 25 words that has the most influence for predicting it as the summary as a health. So you can see that the model thinks the space has a negative correlation with the summary. So space is telling that it's not about the health. So blue one has the positive correlations, the most influence correlation that consists, wavelengths, something like hexagonal, produces, primary. The model thinks this word actually related to health. That's what. And I think the model is actually not well trained. That's why it's telling that it's depending on some word that actually not related to health. For the next model, the Facebook one,
I know we're only using 2 models, but would running more samples on the base one that you're using get a little bit closer, or have you been seeing that it kind of does the same thing? Even
the model actually, as far as I think, the model actually doesn't have James Webb Telescope or scientific data setting in the training set. That's why it doesn't know.
So there's just a lot of labels that doesn't have context to. Yes. Gotcha.
But it can work with health, I guess. So if you put any summary about the health, it can give you like good explanations on the health.
Gotcha.
So for the bird one, it predicted the summary as a science. It's correctly. So it's taking that Hubble has the most influential, and it's true. Wave, observe, wavelength, like the word longer segments. They have some lower influential word, but it thinks that Hubble, wave, observe, wavelength is the most influential, and it's correct because it's related to science. So we can trust this model for the prediction. And it also has all the labels prediction, candidate labels prediction for the history, for education. I just put 2 for just a quick explanation. So for the plot explanation function, you can change here to show all. I just limited it by the 2. If you just remove that, it will print all the candidates explanation. For the last one, that worked perfectly. See, their explanation is actually makes sense. So it's telling that it's related to science and technology, and it's providing you the Hubble, Beryllium, space, telescope, related to hexagonal, or some other words that actually related to the science. So then an explanation for environment or other. You can have the 16 explanation for every level, which word actually influencing to be that label, following that label. And that was my goal, to teach you how the line actually explain the models and which model you should believe in your task. And you can decide by watching the explanation. Without any explanations, if you believe have a model can have 90% accuracy, but But without any explanation, you can't leave that model because it may internally, depending on some spurious tokens or spurious decisions or spurious noises. So yeah, for any model, have the explanation. If that works, you can go with that. So that's my walkthrough to the notebook. If you have any questions, you can let me know.
Awesome. Thank you. Does anybody have any questions about the notebook or anything that he's done today?
So you can play with this notebook and let me know if you have any question or something. And I'm here for helping.
Could you also run this like on a Jupyter notebook or anything like that?
So it's on Colab. So I don't have GPU in my laptop, right? So I just running on Colab. Colab can provide GPU. That's right. So you can just, it's IPYNB file. You can just run on the VS Code. It will run.
Yeah.
It's
universal. Cool.
You can download it pretty easily.
Yeah.
Are there any explanations that Lime is not good at?
Okay, so that's a great question. So Lime not good at that. If you go with the number of samples, the higher you go, the Lime works better. So in the case if you don't have like number of samples is less than do something, it won't work.
Okay.
Totally just dependent on the model then.
Yeah, also
Right.
depends on the model.
Yeah. Okay.
In those situations, have you done like, data supplementation or like data mirroring to create, fake data? To increase the amount of data?
No, Lime does it internally. So it just first, I think, because I don't know the internal actually. So they use some techniques to probabilistically getting the top keywords. They remove it and see the probability of output from the model. And then tweak these things again and again. That's how they get these scores. Then based on the similarity with the real summary, they get another cosine scores, and they put those scores to train a surrogate models like linear regression for the decision. It's a complex, but yeah, for now.
Awesome. Any other questions? No? You want to bug him after? Okay, cool. All right, thank you, Zohar. That was exciting. And then I'll get us kicked off.
Thank you.
Really quick. Hopefully that works. Turn it over. Maybe. Cool. Awesome. It'll scream at me telling me I connected something. Awesome. Well, thanks for joining, y'all. I hope y'all found this informative and exciting. So thanks for Suhar for that demo presentation. I think like live coding is always pretty nervous, but Google Colab, definitely a good decision. You can just click play and it should have worked before. So good point. But yeah, thanks for coming, everybody. Excited to put this one on, and this isn't going to load now. That's cool. That's cool.
We all doing another one next month.
Yeah, so I'll actually mention upcoming events.
Cool.
So actually tomorrow, if you're interested in a bunch of what's going on in the tech community, we will be located down at Techport, San Antonio. I'll be a speaker on a panel there, as well as Christian. I keep calling him out. But there will be a bunch of us, all of us downtown. So if you're interested in what's going on in the community, just have questions for tech leaders or something like that, definitely check us out. There's also a bunch of stuff else going on. There's a Bitcoin walk happening on the weekend. There's AI and Cloud, which is a meetup where if you're interested in just a bunch of different things. I believe that one's virtual. We also have the AI Agent Showcase. This is a part of that series. I mentioned that before our speakers took over. We are, well, not we, but the Geeks group is going to be presenting down at Techport as well. It's a showcase. You'll be a science fair presentation. You'll show off the things you built this past month. If you're still thinking about building something, you still have time. That I think the submissions are due on the 5th, so you have a little bit of time. So if you're wanting to build something with AI agents or wanting to do anything like that, definitely have some time to build there. We also have a coder study group happening that same morning. That is something that happens every month. So if you like reading books, if you like reading CS books, there's a group that meets up and talks about all kinds of different things. They're definitely on a large chapter right now. If you're curious about what they're talking about, they are in that DevSA Discord I mentioned earlier at the beginning of the presentation. Also, more I'll hit on in just a second, but we also have an Unreal Engine workshop happening in June. But yeah, I just talked about the AI showcase. You can get all the information you can from the Geeks and website. So you can see geeksanddrinks.tech/AI-showcase. Definitely encourage y'all to participate in that. Y'all can even use what he built today with Lime. Y'all can show off like maybe something else that y'all did with it, and y'all can go show it off. I'm just encouraging y'all to participate because I mean these are some of our first few hackathons we're putting on in San Antonio. We are also mentioning that I have an Unreal Engine workshop coming up. I'll kind of spill the tea here a little bit, even online. Ansley with the Greater Gaming Society and ACM San Antonio are putting on a game development hackathon through the month of June. So if you're interested in anything like that, and you like game development, that's definitely an option for you. We do have this paid for workshop. If you are an AC member, it's half off. If you have some questions about how much it costs, totally reach out and can work with you on that as well. But big thanks to our partners, Project Cowork and TechBlock. TechBlock helps support us in many more ways than one, as well as the space we're in right now, those that are online and those that are here in person. We are in Project Cowork. If you're looking for a Project Cowork in place, definitely check them out. Pretty affordable. And as always, one of my final notes is feedback. Feedback's important to us. If you have questions, if you have anything you want to add, if you felt like I spoke way too much, or if you just want to see some cool topics happening and you have a recommendation, totally fill out this form. It's just a Google form. Select today's meeting and kind of go from there. But with that being said, that's pretty much all I have. Excited for y'all to come. Excited to put on another event. But right now, tentatively, you're looking at an event happening in next June or this coming June. More coming up after that. So thank you. Thanks for coming. Yeah.
A Unity shop too, or just?
That one's just Unreal Engine. To continue on that topic of that month of June, I have reached out to a couple people. If there's anybody that's interested in putting on a Unity workshop, totally helpful, can help put that on. But we currently do not have the Unity workshop. So, yeah. Thank you. And thanks to our speakers who are. Thank you guys.